Hi everyone. Yeah, welcome to today's class. Today we'll be looking at tutorials on learning about the use of the HOMER Pro for um, energy modeling. And then, yeah, I hope everyone stays safe where you are, and then you're well. So quickly, I am going to be taking you through the um, the software, which is HOMER, and what is the meaning of HOMER. HOMER is a hybrid optimization of mixed energy resource. Uh, yeah, mixed energy resource. That is just the acronym for HOMER. And how is HOMER different from other software? In terms of energy modeling, you have different software for wind, solely for wind energy modeling. And then for some of it Wind Pro that you use. I'm sure you've done that in the previous classes, talking about different energy modeling software that you use or you can use. And then for solar PV modeling, you have a SAM, you have PVCs, you have PVSol, and different energy modeling software. But for HOMER, it's not strictly for a particular technology. So it's a technology for hybrid energy systems. What does that mean? That means that you can have different energy resources from renewable resources to conventional or fossil fuel, such as diesel generator or petroleum or gas generator rise, and then different forms of fuel. All right. So today, we want to look at this software that can help you to combine different energy resources. Also, it's an energy resources that you can use. I am going to share my screen right now for you to see. Yeah, I'm sure you can see the screen. I'm sure you can see my screen. Yeah, so so from this screen, you can see the main the front user interface. So when you launch your HOMER Pro software, either in any of the, right now I am in the Demand building 213. You can also have this software in the library, in any computer in the library, and as well as some other labs where you have using the Anywhere apps. So you can make use of this software. And then when you launch this software, it shows you this page. And from this page, you can start your modeling. So the first thing you want to consider is, this is not so important, but yeah, for a project, you want to put your name, you want to put the description of that project. And then apart from the description of the project, the next thing you want to specify is the location of this project. So for instance, if I want to have a project, an hybrid project of solar PV and, for instance, solar PV and diesel generator for Holden. Now here, I'm sure you can see where I'm pointing at. This is where you're going to enter your location. All right, this is where you're going to enter your location, or you can type in your location here, Holden. Houghton, Michigan. Yeah. Or you can zoom, you can use this zoom to go to city, region, or whatever. So I'm just going to use one. All right, I'm just going to use one. You can use this. You can use any of these to zoom to wherever you want around the globe. So I'm just going to click enter. And then once it gives me that, so already this has shown me that this project is for this area. All right. So once I've logged in this location into the space here, the search space, and then the cursor here has shown the position. Let me zoom, for instance. Let me zoom towards that so you can zoom to it. All right. So it shows you where your location is. All right. And so why do we need to do this? Why do you need to specify your location? This is very important because your weather data for your temperature, for wind, some of the data for solar irradiance that you will be using, solar irradiance or solar influx, will be based on that location. So for every country and in every region, you have different solar irradiance all through the year. And that is why you want to specify where you want that data to capture. So this is where the data will be capturing. It will be capturing Houghton. And then, so already you have this captured in the software. The next thing you want to do, which is also critical, is specifying the discount rate, inflation rate, project lifetime, and annual capacity shortage of your system. All right. So especially for your solar or for your renewables, you want to leave it at 25 years, and then you don't want to have a shortage. But the two that are very important are your discount rate and inflation rate. So I'm not going to talk much on discount rate and inflation rate. These are some of the things that you need to know the meaning and how they work. Inflation rates, both discount rates and inflation rates, gives you the interest rate, and that is what your simulation will be computing in terms at the end of the day in your results. Talking about internal rate of return, and as well as return on investment. So all of that, including payback, but I'm going to keep these for the results section. All right. So I'm keeping this for results section, but you need to know that. So for discount rate and inflation rate, which has to do with interest rate, will be for the country that you're working on. For instance, I have specified Houghton, and then I want to know the discount rate and the inflation rate of United States. So what is inflation rate in United States and what is the discount rate? So that is what I am going to specify. So I'm just going to use any number and then put that number there. So I am going to assume that, okay, the discount rate is, let's say 7, and then the inflation rate is, let's say 1.5. So now I have specified that. You don't need to do anything. After specifying that, you don't need to do anything. Just have it there, and then the next thing is you want to go to your components. So here you have different components or different part of your system. You have the load. You have electric load 1, electric load 2. If you have different loads that you want your technology to serve, you have electric load 1, you have deferrable load. This is also something that you need to understand what deferrable load is. I'm not going to spend much time on it. At the end of this lecture, I will be sending a material for you to, a tutorial material also for you to understand what some of these are. But deferrable load are just basically loads that you want to use from your excess load produced. For instance, you have the solar generating excess for you in the afternoon, and then you have some other load that can make use of. For instance, your pumping machine or any other load device that you want that to take care of. So that is going to be your deferrable load. And then you have the thermal load, you have thermal load 1, thermal load 2, and then the hydrogen. So these are different load systems that you can impute into it. And then the next one is your component. So you have your controller. I'm going to click on the controller. This is what your controller looks like. You have your generator. You can have different, we'll still come back to this. You have different, you can select different generators. You have generic generator that you can select. And then if you have specific generators that you want to add, you can add generator from here. And then you can choose different sizes of your generator. We'll go back to that shortly. And then you have your PV. You can have your PV. You can add also in the catalog. You can choose from the catalog. And then you can also have your generic flat plate PV to use. So in this class, the catalog for all of the components are some of the pre-uploaded technologies and devices with their capacity, with their ratings and specification. All the specifications are there in the catalog. So that the catalog can also actually be very helpful for you to know, to see what different type of device that are available in the market. So there are real-time devices or generators that are in the market that you can make use of. And then the next one is the wind. You can also have the same thing goes for the wind, your storage, your battery, the same thing, converter, and the boiler, the custom, the boiler. You have the hydrogen storage and different devices. You have the hydro, and then if you want to connect to the grid, so you can also specify that this system is connected to the grid. So if you look at the left-hand side, you will see that some of those things that I have clicked are already appearing in the schematic. So this schematic is showing me every component that I am choosing. And then from there, you will see which one works. So you can add whichever component into that schematics. So I'm going to delete that because I don't need that right now. I'm going to delete the grid also. So just have in mind that you can make use of your grid. You can add to your grid. You can connect to the grid because HOMER is a microgrid software, and then it can really work for community energy development or like small regional energy planning and development. So you have your microgrid, and then so I am going to delete the hydro. I don't need it for now. I'm going to delete the converter. I don't need it right now. Remove. Okay, so now this is what, so we still have this. Okay, I still have the boiler. So I'm going to remove the boiler. All right. So the next thing, so the first thing you want to do after entering all of these is to enter your load. So you want to enter your load. And what is your load? So you click on load, electric load 1, and then your load is the consumption for either you're working on a building, because this can also go for the hybrid system, can go for a building, a single building with mixed energy resources, or even single energy resource, either generator only, conventional generator only, or renewable only. So you will be specifying what your peak month is for each of the load. So if your load has a peak month, you have to select that. And then you have to say, okay, what profile is the load? Is it for residential, or is it for commercial, or industrial, or a community? All right. So these are to what extent that you can different load system that you can have in the HOMER. And then the next thing is apart from, so this is going to give you a generic load. I'm going to come back to that shortly. But the other thing is that you can import your load. So, okay, let me say, for instance, before I go to import load, let's say it's community. Our load is community. And then what is our peak month for the load? Let's say it's July, all right? And then I click OK. So this gives you for that area. Remember that we have used Houghton as our location. So this is giving you a synthetic load that have been generated based on some stochastic measurement for this area. All right, for this area, this is what the load looks like. Almost it's a rough idea of what it looks like based on different measures that have been put into the HOMER system. And then, so this is one for a typical, I think I clicked on community. So for this community is, so this is showing individual household, all right? And then for that, it gives you the hourly load for all through the day. So it gives you the hourly load. This is showing you the hourly load. However, if you have idea of what it should be, you can enter that manually, all right? You can change that to whatever it is. If you have hourly load for that particular place, you can change it. For instance, if I double click on this, I can change this to, let's say, 1.55, for instance. And then I can double click on this and change this to 1.58, and then this 1.6. So you can change it as you like, all right? So that shows that for the load. Alternatively, you can have, so I'm not going to close this because we'll keep working with this load. So let's assume we want to have a second load, or even this could be like a first load, the main load. But because for the sake of this tutorial, I'm just going to click on the second load, all right? And then I'm going to show you how you can import. So you can actually import from Excel file. If you have Excel file of your granular load profile for a particular place all through the year, and that is going to be 8,760 hours. That makes a year. So you want to have that all through the year, and then you click on import, and when you click on import, you go to where you have saved the file, all right? And then once you're done, you click open, and then it opens, and then you have it. So that is going to automatically show there. So because I didn't click anything, there is nothing that you have here. If you have some other questions, maybe later on, you can write me or you can email me. We can talk more about other load, how you can have the other load. So I'll go back to, so I will click, I will cancel this load because we don't need it, because there's nothing there. So I'll go to my first load. So again, to the first load. So here you have, so with this, does it mean that this particular load is completely useless? No, because it still contains something that you can roughly use for this area. It's a probabilistic, it is stochastically generated, all right? But to be able to use this, you would need to have some other form of input, which includes day-to-day variability. It also goes for other load, which are originally gotten from your meter reading or whatever for the whole year. So, so here you can select the variability per day. So all through the year, it shows you, so this one is telling you that this load will vary 10% day to day. And the variability means in some day, it could be 10% more or 10% less. And that is going to be your maximum. And then the step-wise is going to be 20 steps. So 20 steps means the number of times that this variability is going to show, all right? So, and that is that. So your load can be AC or DC. You also want to specify that. You can always specify that. And then I'm not also going to go deep into what AC and DC loads are because of the time. And I think those are some of the things that you may want to check in to understand how that works. So, but for this, so you have this load, all right? And then this shows you, so you have this load, so it shows you the seasonal profile, how it looks all through the year. And this is a typical day, how your load profile looks like, all right? So after selecting this, now we have our load. The next thing is that we want to have our components. So this is just going to be a simple design. So let's have our PV. So when you have your PV, generic flat plates, let's choose generic flat plates, and then you click on add PV. So once you add PV, your PV is added to your schematic. So always, whenever you click, always look at your schematic. This is where everything that you have selected, this is where it's being displayed, all right? So, and then you can add or remove any other. For instance, if you click add or remove, it's going to show, and then you can also add another generator. Let me show you, add PV. So you can see now I have two PVs, flat plate, all right? So, but I am going to delete one, you know, to keep this simple, just for your knowledge. So once you have your PV, the next thing that you want to give your parameters for your PV, all right? And that comes for the cost component of your PV. So the capital cost, what is the capital cost per kilowatt for that? So you need to know what the PV cost is. So right now, this is showing us 2,500. I guess this is kind of 5 years or 10 years price of capital cost of PV, because right now the prices of renewables are falling drastically, especially for PV. And so let's say we have 500 per kilowatt hour. All right, and then the replacement cost would definitely be about the same. So let's say 500 per kilowatt hour. Per kilowatt, sorry. And then your O&M cost. O&M is operation and maintenance of your PV. And then that is just for clearing of the surface of the PV, cleaning of the PV, for instance, for people from other countries or from other places where you have dust or you have birds, you know, pulling on the PV. You don't want your PV to be blocked or anything to obstruct the influx of the solar influx. So that also comes with a cost, you know, annually, and then you want to put that. So let's leave that to $10 per year, so per kilowatt. So this is $10 per kilowatt per year for the operation and maintenance cost. So after that, you can also select your derating factor, all right? So you can put, so this is where the sensitivity analysis comes into play in the design of your system. So HOMER is typically a simulating, optimizing, and simulating, optimizing, and what is the last S? It simulates, it optimizes. I forgot that's not really important. So now it simulates and then it optimizes, and it also synthesizes all of these that you have. And so you can have your sensitivity. So simulating, optimizing, and sensitivity analysis. So your sensitivity analysis is having different variables that can change. Now you want to vary your input parameters. You want to say, okay, for instance, I'm going to close this. For your cost, you can vary this as well. If you click on more, you can vary the cost of your PV. All right, you can actually click to add new. So when you click to add new, it shows you, you can say, for instance, okay, if in another case, per kilowatt is 750 or 700, let's say 750. So you can add, you can have incremental values of the cost component, all right? And the replacement cost is also 750. All right, and then it shows you, and then you can also add more. So you can add more as much as you want. That is for this, you can add different components, and that is part of the sensitivity. So look at this sensitivity variable editor. It's also you want to look at it based on the excuse me, based on the lifetime. So you may want to carry out your sensitivity along lifetime, usually 25. Some can look at, okay, what if the lifetime is 20 or 22, from 20 to 25 or 25 to 30. And then you will want to see what your system will look like in terms of the cost, in terms of meeting load and all of that. All right, so I'm going to cancel this and then I'm going to close this because I just want to have one. Okay, so we have this, and after, so your derating factor is also how much your PV will have derated after the 25 years. All right, so that's the derating factor, and then you want to put that into consideration. So you add, so you can also have search space. So now, what do you use? So here you have capacity optimization. In here, you want to have HOMER optimizing just this particular capacities to give you all the capacity possible. But this is going to be a very huge one. So you might want to put a search space that, okay, my bottom and top capacity is, let's say for the community in Houghton, you want to specify, okay, let's say if I have 200 kilowatts, or I say 220 kilowatts, 40 kilowatts. You add again 60. Let's make incremental by 20, 80, and 100, and let's say 120. So based on the load. So you want to use that to based on your load. If you look at your load here, your peak load here is 23 kilowatt hour. So if your load is 23 kilowatt hour, then do you want to have 120 kilowatts? Sorry, your peak load is 23.44 kilowatt. Then you don't want to have up to 200. So you want to have like 20, 21, 22, 23, 24, 25, 24, 25, all right, 24, and then 25, and let's say we have 26, all right? So we want to see how each of this capacity can accommodate for your peak load. So after setting this, then the next thing you want to set is which other technology that you want to use alongside your solar PV. So you know that your solar PV doesn't work in the night, and then you want to have a backup or something else. So either you want to have a generator, or you want, which is this, or you want to have a battery storage, or you want to have wind. All right. So even with wind, you could have that intermittency at night where the wind is not blowing to cover your demand, your energy demand. So you want to have like either a storage or a generator, any other generator. So let's click on generator, for instance. And then we have, let's say we have 25 kilowatt fixed gen. This is a generic. Like I told you earlier on, you can click on the catalog and it shows you different generators. So this is a manufacturer, different generators with their manufacturers and the fuel that these generators are using. So like this is Caterpillar product. And then if you go down, if I scroll down, you see different products. You have Cummins, you have Danvest, you have some generic, you have Innovos, you have GE General Electric, you have Kohler, so you have MTU, you have OJA, so different manufacturers, all right? So you have some of these generators for you to use, so you can choose here. But for the sake of this tutorial, I am just going to use a generic, and then I'm going to say so in choosing your generator, you want to see what your load looks like at night. So if I go back to my load, for instance, so this is my load. And if you look at your load profile on a typical day, you want to check, okay, from 4 p.m., all right, from the 16th hour of the day up to the night, what is the maximum? What does the load look like? It's about 10 kilowatts, all right? So if you want to use that, then I'll go back to the generator again, generator, and then specify, so you can specify 10 kilowatts. You can also specify 25 kilowatts, all right? Or you can use generic. So if you use generic, you can add to it. So for your generic, if you specify auto size genset, if you look at this, it's showing auto size genset. And what does it mean? It means that your generator will be sized according to your unmet load. Unmet load are load that are not met by this technology, which is your PV. It is the unmet load. So your generator will be sized automatically by the system. Okay. So, and then you can, but the problem is having auto size generator is that if you're thinking of using a generator by a manufacturer and your result, your calculation, your system is giving you a result of, let's say, 25 kilowatts of a particular generator, and a manufacturer does not have that size of that generator, then you have to go back to your system, all right? And that's why the auto genset, that is a small setback of the auto size genset. So, but let's assume we use this, all right? And then we want to specify the capital cost and cost of all the parameters of this generator. So let's go to the cost, generator cost. So initial cost, this is the initial cost that the system has also generated based on some of the real-time data that are imputed into the system. And then the replacement cost, this is the replacement cost, 500, and we're just going to use it, but you can change it. Let's assume we change it to, let's assume it is 350. And then replacement cost, say, is 300. And O&M cost, that's the operating hour, so per operating hour. So your O&M cost is per hour. And then you have this, let's assume it's 20, all right, $20 per hour. And then you go to specify fuel. So for your fuel, you can choose manage fuel, all right? In manage fuel, you want to add which type of fuel that you're going to use, all right? You can add fuel. You have different fuel. You have diesel, you have natural gas, you have Arctic diesel, you have biodiesel, you have heating oil, you have biogas, you have ethanol, gasoline, and different types of fuel that you can choose from, all right? So let's say we use diesel, all right? We say add. Okay, this is another addition, so I'm gonna close it, and then I will go back to it, to my generator. So I have all of this, so this is my fuel. And then you want to specify the price of diesel fuel per liter, all right? I know here in the United States, you use gallon per gallon. So how many liters do you have in a gallon, all right? And then you divide that by the price of that, and it will give you a price per liter. So if we do a little computation, diesels goes for, let me quickly use calculator. All right, we'll use calculator briefly, and then we'll just see what that is. This is just a rough idea for you to know what is going on. So per gallon is, for instance, 2.99 diesel is per gallon. And how many liters do you have in a gallon? It's about 3.4. So you say divided by 3.4, and that gives you 0.879. So let's say 0.88. So this is, so you can now put your price here, which is 0.88 dollar, that's 88 cents per liter. All right, that is the price of your diesel fuel. So you have to specify this. These are the some of the input that are very critical that you must not miss. And then you can also vary that. So this is where, like I said earlier on, the sensitivity analysis comes into play. So that is varying the price. What if the prices have changed, would change, or it changes? We all know that all these prices at the pump prices changes every now and then. And then you want to say, okay, what if it increased to 0.9? What would it be? What will 0.95, and let's say 1.0 and 0.9, 0.95, then 1.0, then 1. 1.05. All right, let's just say this is so why do you have to vary your costs? Because these are not fixed costs. They are usually varying every now and then. These are changing costs. And as well, you want to see what your levelized cost of your energy cost, your capital, and all of that, what is going to be, what your system cost will be with all of these different costs. And that's why I said that the HOMER is the basic operation of the HOMER is simulation, optimization, and sensitivity analysis. So this is part of the sensitivity analysis. When you add some of these, you vary the cost component or other parameters of your devices. So I'm just going to click OK. So, and then you can also specify maintenance scheduling. So if you want to schedule maintenance, you can put when, what time you want to, you can add time, you can do whatever you want to do with your scheduling. And then this shows you when, so you can say, for instance, in May, you want to do maintenance of your generator all through or at a particular time. So for those times, that means that your generator will not be working. Your diesel generator will not be in operation. And so you want to do it at a time where when your solar PV can cover your demand, all right? You want to do that at a time when it can cover your demand, or you want to add an extra maybe component, energy device or technology, maybe wind or battery or something to cover up for that. Or you want to go away with the diesel generator and just make use of storage. All right. So that is that specific. Okay, site specific. So these are some of the things that you might also want to put there. So lifetime hour. So this lifetime hour, usually most diesel generators, the life cycle is 15,000 hours, which is typically, this is typically like 2 years. All right. So before installing or before you need to change to replace, that component. Okay. So now we have, basically we have two components. All right. So you can add other components. This is wind. You can add, like I said, you can add wind, you can add this, and you can also add grid. Like, okay, so if your generator is not working, maybe your system is grid connected. That means that you can add your grid, and then you can get electricity from the grid. So, and now you can see just below the schematic, it's asking me add solar global horizontal irradiance. All right, so that means it's asking for the solar resources. So if you click that, all right, and then you say, once you click that, you go to download from internet. All right, so when you click download from internet, it's asking you, do you want to use NREL data? NREL is National Renewable Energy Lab. So data that is already predetermined by NREL for this location. Remember, you're still talking about this location, which is Houghton. So you can use NREL, you can use NESA. That's the aerospace data. So let's say we want to use NREL, all right? And then you click on download. Okay, so you see your resources were downloaded successfully. So you click OK, and then it shows you now, this shows you how your, what's it called now? So this is showing you the irradiance, the blue is showing you the irradiance, and this is showing you the clearness. All right, the clearness. This is a point where you have, what is clearness? That's where you're not, the timing or how much of non-cloudy period that you are having with your solar resources. So that is for that. And then you have it here. You have different clearness index. You have a daily irradiance in kilowatt hour per meter square per day. It shows you from January to December, as you have it here. So the next thing for you to add is, it's also showing you add converter. So you need to add converter. You click add converter. The same thing, you can use generic. You can use generic large free converter. You can use system converter, whichever one. Component will replace library continue, yes. So this is showing you different sizes. So based on what we have, you can also specify your converter alongside your PV. So you have 20, we have 20 before, we have 21, you have 22, you have 23, you have 24, and then we have 25. So let's say we have 26, I can't remember, I think we should have up to 26 there. And then it asks you for your cost, all right? You have to put the cost of the converter, all right, per kilowatt. So let's use hypothetical value for that. Let's say 100, all right? I'm just gonna say 100 per kilowatt. So 100, and then, yeah, it's 0 for O&M, for instance. So all of these are things that you can play with. You can also change the lifetime depending on the manufacturer. If you know that, okay, this is just a default, by default, the lifetime is 15 years, but there may be a new product that has lower or higher lifetime, and then the efficiency and all of that. So you specify that. So do you want it to work in parallel with the AC generator? You create it, yes. Or you want it to work. So if you click, I want you to look at the schematic as I click on work parallel with the AC. You see? So it already shows that the converter, it indicates a red sign. If I click on it again, it's removed it. All right. So that is that. And then, so here you don't have any suggestion. So this suggestion box shows you when something is wrong. If you remember, initially we had two red warning. The first one was that, okay, your GHI, that's global horizontal irradiance, is missing, which we added. You know, remember when we added that, the NREL data. And then it also shows that we need to add a converter. So if any other thing is missing, or you need to pay attention to some other things before you run your system, it shows. Then the next thing is your resources. So already we have added HGH, and then rather than HGH, you can be direct normal irradiance, all right? I'm not going to go into the difference between direct because of time, irradiance, then the wind. So you can also have the wind. I'm not also going to go on how the wind affects the operation of your solar PV, but for you to add that, you click on the download data from internet, and then it brings that out, all right? So this is also still for this Houghton area, all right? Then temperature, you can also download that. It gives you automatically, all right? NASA, because we have specified, okay, this gives us NASA data, which have been previously specified. So then wind, yeah. So now, what else? You have different component resources that you can add If you want to add some other things like biomass, fuel or something, you can also add that. So that's it. Now project. So for your economy, this is where you have, so what you have entered in the beginning as shown here, remember that we entered 7.0, all right, for nominal discount rate and the expected inflation as 1.5. And so all of these come and then you can change it. You can also change the currency of your costs. For instance, if you are working on a place in a location that is maybe in India or something, where is India? Okay, so you have India, so Indian rupee. So you can change it to Indian rupee. You can change it to different currency. So now the real discount rate is giving you 5.42 because your real discount rate is the difference between your nominal discount rate and your inflation rate, all right? And that's going to give you, okay? So that is where you specify. So you can change the currency here. Also, you can put some constraints in here, maximum annual capacity shortage. So if you want to have capacity shortage, what is the maximum? You specify it. Minimum, you specify it. Usually it's like 0, you don't want a shortage, okay? And then other things that you want to consider. Then emissions, you can also put it, but another thing that is very important is your optimization. So how do you want to optimize this? So do you want to do you want to allow system with multiple generators? If you want to allow it with multiple generators, you specify. If you want to make it just single generator, if you want to allow it with 2 types of wind turbines, you specify it. But for now, we're not using wind turbine, so I delete that. Issue warning in if an off-grid system has a maximum renewable energy penetration greater than 55. So you want to specify that too. So that is, and then you have other things like search space. These are for your sensitivity analysis. So this search space is, look, you can remember that we entered the PV sizes in for each component. So these are the sensitivity that we have for all of that. And then, okay, we've done sensitivity. So sensitivity for fuel, we also have our sensitivity for fuel. You can see that. And so you have all of that. So now you have simply all of the components that we want to have. You have specified some of it, and then you go to calculate. So you can see on the right top right hand side corner, you have calculate. So once you click on this calculate, it simulates your system. So let's click on that, and then you wait for it. Piam. And so you have your result. All right. So when you have your results, you can see now reading the result. What does this tells you? All right. So this is telling you, or this is showing you different sensitivity cases that we have created. If we didn't create any sensitivity, then it's just going to show you what the maximum is. Now, if you click overall result, this is category. So if you categorize, if you click overall, you will see all the results that I've created. This is hundreds of results that you have, different combinations. All right, these are different combinations in terms of capacity. For instance, if you look at this, this is 20 kilowatt of PV with 26 kilowatt of generator with 23 kilowatt of converter. If you look just above it, this is another combination. So this gives you different combinations and different costs that comes in. And that is the cost is that usually look out for is the COE, which is your levelized cost of energy, LCOE. So you can see different costs for your for all the combination of the system, which is 60 cents. This is pretty on the high side. And why is on the high side? It's due to perhaps most likely the generator that you have with it, and then the price of diesel that you have on that. So it also shows you the production. It shows you. So if you, for instance, double click on one of the results, all right? I'm going to double click on this, the first one. Double click on it, all right? And then it gives you this. So you can also see your total NPC, that's present cost, all right? So your present cost for it is $483,000. Levelized cost is 0.59, and then operating cost is 34. So that is what you have, and this is for fuel at 88 cents per liter. All right, and then you can check how it works. So this is the cash flow. You check what the cash flow is on a yearly basis up to the 25 years. All right, this is how your cash flow looks like. Your discounted, it shows you that. Then you can also see how the your system is performing. So here you see excess load. So this is excess electricity that you're generating, which is 32%. And then you want to ask yourself that what am I going to do with this excess load? Do I want to change my system? Do I want to adjust my system? That's why it's more or less a kind of optimization you have, and it's iterative. You can go back to your system. This is not final. You can go back to your system. I will show you briefly how you can go back to your system and then change some of the parameters. All right. So to make sure that your load, your excess electricity is minimized. All right. Then unmet load. There's no unmet load, capacity shortage, there's no shortage. And then you have every of these. You have full summary, you have generator, the performance of your generator, you have the penetration. So you want to have, you want to know how much of your renewables is penetrating. And then your renewable energy penetration is a function of the amount of solar resources that you have in that system. All right. So, and then your converter, your generic flat plates. So it shows you the main output and everything that you have. So this is the cost summary again. I don't know if there's anything that I have not opened. Yeah, this is very, very important. And so now, this is where you want to convince your investor, or you want to convince the project owner what this system will cost you and what is the performance. So this is the present worth. I'm not also going to go into this economics. It's something that you can go and read and understand what your present worth is. What does it mean? The annual worth, that's how much that will be annually, and the return on investment. So for instance, this system is showing minus 6.7% return on investment. That means it's not a viable project. All right. That means when it is negative, that means that rather than having return on that investment, I mean, a negative return means that you're losing, you're on a losing side. And then discount payback period, like that's why they're like, they're showing you are not available because already you are on the negative side. Okay, that ends the tutorial. I am going to close this, and then, so like I mentioned, you can go back to your system to, by clicking design, to know, okay, what is going on. So when you go back to design, you can click on any of the components and work on it, all right? And then, yeah, that is what you have. So I will also be sending some other materials, tutorial materials, that you can read and read. And then if you have any questions, most likely I'll be available in the class briefly to answer some of the questions that you may have. Thank you, and then I hope everyone stay safe. All right. Okay, so